The first presentation today on stage Alice is being held by Dr. Carsten Sapia. Dr. Carsten Sapia is the Vice President for Strategy, Governance and IT Security at BMW. And he's presenting his views on quantum computing, or the views of BMW and his views on quantum computing and how to explore automotive applications. And with this being said, I want to directly hand over to Carsten and to your presentation. The virtual stage is yours.
Lucas, thank you very much for the introduction, and thank you also for giving me 10 minutes of time to explain why we really think that quantum computer will be a game changer for the automotive industry, and explain our strategy on how we can develop a German-European ecosystem that really drives the industrialization of this technology. Let's start with the why. So our BMW Group journey in quantum computing started in 2017. So we're now 5 years into the journey, and along this path, we have actually, in the meantime, identified more than 50 use cases along our whole value chain that really look very, very promising for the application of quantum computing. Mainly, they fall into three big categories, which you can see on the left side of this slide. One big use case cluster is definitely around our core business. The automobile is probably one of the most complex industrial products. So you can imagine that we have heaps and loads of very complex processes and are very keen on optimizing them. So for example, production planning, what is the sequence of vehicles we produce in the plant to minimize setup times and so on. How do we optimize our logistics chains to have the right parts at the right time, at the right location with the least cost? I'll later on show a little bit also about robot path automation. So a lot of robots in our plants, and we have really very positive experience on how we can optimize robot paths along these ways. So these are just a few examples around process optimization in, that I think are applicable across the automotive industry. The second very interesting cluster is material science. I mean, examples like the design of batteries for electric vehicles, but also optimizations around fuel cells for future vehicles are really areas where quantum computing will give us the necessary speed and quality that we need to drive this to the next level. Third application area is classical numerical simulation. So about 80% of our high performance computing workload goes into virtually simulating, for example, crashes, but also, for example, aerodynamics, water flows, different kinds of things. So if you imagine that today, most of the vehicle development process is carried out virtually, there's huge fields of application here where I think the power of quantum computing can really help to give us better quality, quicker results, and more efficient processes there. So I think it's very clear. Yes, it makes sense to invest in quantum computing technology. Now the question as an OEM is, what is the right strategy, and how can we actually help to also drive building up the ecosystem that we need for this? And our basic belief is that we need a strong and sovereign ecosystem in Germany and Europe to drive the industrialization for the industry here. And I mean, probably you've seen it in the press, BMW Group follows a diversified approach. So I think pillar one is we need really strong and good cooperation with university partners. We need a very application-oriented research going on, and we definitely need a university to produce talents that are very skilled in those new technologies. That's why we have decided to endow 2 chairs, one at the TU München and one at the RWTH Aachen, exactly for this purpose. We also think that we need a strong cooperation across the industry and the mainly German and European industry. So that's why the QTech comes in. We have co-founded the QTech, and I'll talk a bit more about this in a minute. And the third pillar of our strategy is to build strategic partnership with startups in this area, but also, of course, with very established technology partners that will give us the hardware that we need to run all the applications that we see for our business. Yeah, I mentioned the QTech. I think the QTech is a very interesting initiative. It was co-founded last year, and you can see all the logos of the participating companies there. I think it's very good cross reference of all the industry we have in Germany and Europe. What is the idea of this? If we want to make quantum computing successful, we need, of course, good technology, but we also need a market that requires this technology so that it becomes worthwhile for technology providers to really invest. And I think that's where the QTech is an excellent platform to actually create use cases, to create a market for quantum-driven solutions. And that's why we are very much active in this area, for example, also contributing use cases, contributing benchmarks into this consortium. And also, for example, last year we had a quantum challenge where we actually invited other companies to actively explore real-world use cases. Real-world use case is, I think, the good segue into my next slide, because I don't want to just talk theoretically, but also want to give you a real-life example where we have already applied quantum computing and quantum-inspired optimization techniques. So you can see already on the left-hand upper part of the slide what it's all about. So one concrete example we looked at is the optimization of PVC sealing robots. So in a car production, wherever metal sheets meet, there is a risk of corrosion. And this is where robots apply those PVC sealing. This is quite a complex thing because there's more than 200 seals per vehicle that have to be applied. The geometry of the car, of the underbody of the car, creates a lot of restrictions and constraints that the robots have to look at. Of course, there's more than one robot, and the robot passes cannot cross. So as you can see, it's a very hard optimization problem to find the right path for the robot. And there's, as you can see, a huge amount of possibilities. And what we have done, we have applied a hybrid optimization approach. So we have looked at the optimization problem, we have modeled it mathematically. And then part of this optimization problem is still solved in classical numerical solution, and part of it is used by a quantum-inspired algorithm. And for us, really positively surprising result was that we could improve the robot runtime by about 10%, which sounds quite small, but if you imagine that you can actually in this part of the production ramp up your production volume by 10%, that's really a very big step and really encourages us to further investigate possibilities in this area. And like I said, this is only using quantum-inspired algorithms. We are not yet in the stage where we really apply real quantum computers to this problem, but it already makes us very bullish when it comes to this technology and the possible application. And this is, like I said in the beginning, only one of 50 use cases which we are currently working on. So that's definitely a very promising technology. So coming to the summary of my pitch, why are we investing as a BMW group into this topic, and why are we also very positive that it will be a game changer in our industry? So we see a number of use cases along the whole value chain. What is our approach? We need to drive industrialization because the technology only becomes available once it's industrialized, and this is where we see a big responsibility on our side to really drive an ecosystem development, consisting of our university partnerships and also the chairs I mentioned, the industry consortium, so close exchange between the different industry partners when it comes to use cases, when it comes to creating a software market, an application market for quantum computing driven applications. And the third thing I wanted to get across is basically, or I haven't talked about this so much, I think quantum computing will, for the current industries, even open up new business model ideas, new possible business models. So if you think about an optimization problem and a new way of solving this optimization problem probably occurs in many, many industries. So this is certainly a very interesting business opportunity as well. And of course, we are also thinking about, is this something where we want to invest further on? Yeah, so that's basically my quick morning pitch, where I wanted to show the perspective that BMW Group has on this technology and the use cases we are having. And I'm happy to continue this discussion. So if you want to contact me through any of the channels, happy to answer your questions. And with this, I want to give back to Lucas. Thank you so much for the airtime.
Thank you, Carsten, for the very interesting insights. So I will address like one or two questions to you as a follow-up or as a wrap-up of your very interesting presentation. So the first question I have is regarding HPC and quantum, or the continuum you described. So when do you see the real quantum hardware from relevant providers to be ready for the real quantum, the use of quantum technologies, quantum computing, then, as you use HPC at the moment?
I mean, that's $1 billion question, right? So I don't think there will be one point where you really have. So as you said, it's a continuum. It's a process, and for the next year, I really see those hybrid solutions that we described. I think before we really see those things 100% on quantum computing, probably there's 5 to 10 years. So we're in there also for the long term. So we're not kind of having unrealistic expectations there. But as I said, even if the hardware is not ready, already now we can see the benefits from this technology.
Very helpful, thank you. And the second question I have is really regarding the interaction in the ecosystem QTech you mentioned. There's like the big players from the German industry and the German economy as a whole are part of QTech. So what have been your experiences yet? So how was the exchange? Have you found synergies with partners from several industries? Can you give us some insights?
Yeah. So to be honest, in the beginning, I was a bit skeptic, but I was very positively surprised. Why was I a bit skeptic? Because it's an approach where actually you meet as a circle, and then everybody in the circle commits that they will actually contribute something to the consortium and not being paid for it and so on. And everybody committed to do this on top. And of course, I was thinking, is this possible? Does it work? Will really every party be contributing actively? But I tell you, it was a very positive surprise. So the current exchange is really very fruitful, and we see that there's many similarities in the problem landscape where we can actually really work together to get the foundation. For example, I mentioned benchmarking, right? So if we in the future want to compare different kind of approaches, we need a benchmarking set for the industry where we can benchmark certain algorithms, certain technology. This is something that we are developing together, and we see real world results that are really driven by industrial practice. So overall, it's been a short time, but it's very promising so far.
Thank you for the insights, Carsten. And I think we will meet again at several points of time, especially as this topic grows, and latest next year at Quantum Summit. Thanks a lot for your presentation.
Looking forward to it. Thank you so much.